All right, so we are recording now. So let's get going. A couple things I do want to mention. Let's see. I mentioned last class that I would be posting the questions for your master and his emissary paper. You guys got the email that I sent out about that? I think I sent it yesterday. Anyone get the email that I sent out yesterday regarding the? Yeah, I see one nod. I did send out a email yesterday via Blackboard. The questions for the master and his emissary paper are posted on Blackboard. There are two questions or two topics. You can choose one topic. I am happy to meet with you. We could, email exchanges, or better yet, meeting over Zoom to discuss your paper topics. I'm definitely willing to be active in the brainstorming sessions and helping you flesh out your idea and all that. And I can even give you feedback on the paper itself if you've written something and you want specific feedback on some specific aspect of your paper. I am more than happy to provide feedback on the paper. I'm not willing to just read the entire thing and basically give you general feedback for the entire paper. If you want me to read the paper and get feedback, that's fine. You just have to give me kind of specific things that you're worried about or specific things you want feedback on. That will be due. I don't remember the exact date, but it's basically the stop. I think it's it's in May, the last day before finals week. That Friday stop day. That's when I'm going to have the paper due. And I believe I already put the due date on Blackboard. So if you have questions or anything you want to talk about regarding that paper, definitely let me know. Otherwise, plan today is finish up talking about chapter 6, get started on some chapter 7 stuff. Anyone have questions or comments before we get started?
I know that a few other people said this in the chat, but some of us didn't get the email.
Huh. Wait, I want to verify. Did anyone get the email yesterday? Say yes if you did get the email.
Yes.
Okay, I did get at least one yes, but I will happily resend the email. I always send it out via Blackboard, so it should go to your KU email. So that's the one you need to check is your KU email. I will definitely send that out again after class. I also remind you, though, it's just posted on Blackboard. The essential information is on Blackboard right now. The email just contained a couple extra non-essential things. The essential information is on Blackboard. It's the link that I created. It was called Master and His Emissary Paper. But I will definitely resend that email. I'll try and figure out why some students might not have gotten it. Any other questions or comments?
Can you clarify the due date for the project?
Yeah, I don't remember the date off the top of my head. It's stop day.
Okay.
And if you look inside the Master and His Emissary paper folder, I'm almost positive that I already put the turn in, the submission place there, and it should say the due date. And so check that, and whatever that due date is, the official due date will be stop day, whatever that Friday is of week, week 16, that Friday. So the very, very last day of classes before final exam week. That's when it's going to be due, that Friday before final exam week.
Okay. I was checking just because yesterday I checked the Blackboard link to submit the paper and it said April 8th. So I don't know. I can check again today, but I don't know if it was just a mistake in my part or I don't know.
Now you
I can also see that it says April 8th.
Okay, well. then I probably meant to say May 8th. That's probably what it was, because I believe May 11th is when finals week starts. So I will fix both of those things. I will resend the email, and then I will adjust the due date. Thanks for bringing that to my attention. I now want to look at the calendar. It's going to be that Friday. It's stop day, which I'm looking at my calendar here, trying to find the calendar. Does it have one on the app? Yeah, here we go. Come on now.
Stop day falls on the 8th.
Yeah, so I accidentally did April 8th instead of May 8th. That's all that is. So I'll definitely correct that. It is definitely not due this Friday or whatever. It's definitely not due in 5 days because we haven't even finished the book yet. So definitely it's not due yet. It'll be due in about a month, a little over a month.
Cool. Thank you so much.
Yep, no problem. Any other questions or comments, people? Okay, there's two things I have to do is resend the email, fix the due date. I can remember that. Okay, so last time we were talking about this slide, and unfortunately the link apparently that used to work. That was a great video, but the person who posted, I guess, didn't want us to be able to watch it for free anymore. And so I did send out those other links recently that had some other videos about disorders of consciousness, particularly locked-in syndrome. Hopefully you got a chance to watch those. Actually, I should probably backtrack a little bit, because the reason we're talking about disorders of consciousness has to do with this idea of mind reading, which is talked about in the textbook. Mind reading, once again, is the idea that you can actually program a computer to analyze your brain activity. The computer is able to read out an fMRI responses or EEG responses, and the computer is eventually able to learn, oh, when this person is thinking about X, this is what the brain activity looks like. When this person is thinking about Y, this is what the brain activity is looking like. And then eventually the computer can get smart, and it can look at your brain activity and be like, oh, right now this person is thinking about X, or right now this person is thinking about Y. So it's a way of training computers to decode or to analyze brain activity, to basically read the mind of the individual who's producing that brain activity. This is really valuable, in particular for these patients that have locked-in syndrome. So we'll get to locked-in syndrome. I guess first we should talk about some of these other conditions. Vegetative state is basically when a person is in a coma. They might kind of have some movements, but basically there's no indication that the individual is conscious. When a person's in a coma, they're completely unconscious. They're basically not moving, except for maybe very minimal movements. Obviously the person's not able to talk with you. And there's really not too much reason to believe that when a person's in a vegetative state or coma that there's any consciousness. They appear to be unconscious. When people are coming out of a coma, though, however, they kind of go back and forth between the coma state and what's known as a minimally conscious state, when the person might temporarily show some signs of being conscious. They actually might be able to kind of communicate a little bit verbally for a while. They clearly can move their eyes around a little bit when they're in a minimally conscious state. But one of the things that often happens in a minimally conscious state is they'll kind of revert back to a coma. So it's not like when you come out of a coma that it's always just like that, where you just come out of it really quickly. You kind of gradually come out of it, and part of the gradual is waxing and waning between this minimally conscious state back to the coma, until eventually, though, you will, hopefully at least, you will completely recover and then be in a fully conscious state once again. For our purposes, though, the most relevant to this mind reading idea is locked-in syndrome. In locked-in syndrome, a person almost appears like they're in a coma because, as it says here, there's really no behavioral signs of consciousness. The person is basically completely paralyzed. They might have a couple of reflexive looking movements. They might move their eyes a little bit, but there's not a whole lot of reason to believe in locked-in syndrome just looking at the person outwardly that the person is conscious. However, there's been some recent research using neuroimaging techniques, fMRI, PET, EEG, maybe MEG to some extent, that actually indicates that these individuals that appear outwardly to be completely unconscious, they actually are conscious. And if you watch those videos, you can see how they knew this, how the researchers figured this out. And that the main thing I wanted you to learn from those videos is kind of the technique which is used. And the technique is pretty interesting. The technique involves basically asking the patient questions which you know the answer to. Like, my mom's name is Sherry. So if I were in a locked-in state, the researcher might say something like, if your mom's name is Sherry, then I want you to imagine cleaning your house. That would be like, and so basically what they're saying is, if the answer to a question is yes, I want you to imagine you're cleaning your house. But then they might ask me another question, like, the name of your mom is Martha. My mom's name is not Martha. And so for a question like that, I would say, no, that's wrong. That's not true. Then that's the answer to that would be no. Is your mom's name Martha? The answer is no. And they would say, if you want to give a no answer, I want you to imagine playing tennis. And so they don't just tell you to imagine yes or imagine no. They actually tell you to imagine in your mind different activities. So they'll imagine, if they basically say, if the answer is yes, imagine something like you're cleaning your house. If the answer is no, imagine yourself playing tennis. And then they'll start to ask questions of these individuals, and they find out that when the answer is yes, the person appears to be imagining themselves cleaning their house. And when the answer is no, the person will imagine themselves playing tennis. And the the mind reading allows the person to communicate with researchers with their thoughts alone. The person can't talk, the person can barely move might even not be able to move their eyes, but the person can think about certain things. They can imagine certain things in their mind, and they can answer yes or no questions with their mind. So the two most important things I want you to know about this, I want you to know what mind reading is as a technology. And I want you to know kind of methodologically how it works, how you make a person, like what you ask the person to think about when they want yes, or to think about when they're answering no. And then I want you to know what locked-in syndrome is. Locked-in syndrome is what we just talked about. Person is conscious, but they can't communicate that at all with their body. They can't move at all because of paralysis. So those are the main things I want you to know about this: mind reading, what locked-in syndrome is, and how mind reading is used to communicate with locked-in syndrome, the method. Any questions or comments? Okay, that's it for chapter 6. Okay, attention is now what we're moving to. So with the conclusion of chapter 6, remember chapter 6 was part of that kind of two chapter sequence. Chapter 5 was mostly about sensation. Chapter 6, which is what we just concluded, was mostly about higher level aspects of related to perception, higher order aspects of the mind. Now we're at chapter 7, we're talking about attention, which I think attention is something that we all kind of intuitively understand, because we understand the idea that when we're in class, we have to pay attention to the teacher, things like that. So we have an intuitive idea of what attention is. This chapter will definitely go into more depth about some of the cognitive neuroscience research on attention. First, I wanted to just define it, even though I think you guys have an intuitive understanding of what attention is. Here's kind of the definition. It's about selecting things in the environment to kind of prioritize mental processing for. One thing that is not part of this definition, which is important, is that an aspect of attention is that you prioritize certain aspects to analyze or to process in the environment, but it comes at the cost of other things in the environment. And when you attend to one thing, it kind of requires you to ignore something else. So attending to one thing is selecting one thing to process, but it comes at the cost that the other things in the environment will tend to be ignored. So there's the thing that you pay attention to, but then there's also the things that you have to ignore in order to pay attention to that one thing. So that's kind of our definition of attention. In this first parts of this chapter, we're going to talk, well, first I'm just going to define covert versus overt. Covert attention is the idea that you might not be looking directly at something, but you can still be paying attention to it. Like right now over here, I know there's this tree out the window, and right now I'm kind of looking at my computer, but I'm actually attending to the tree. I'm kind of looking with my peripheral vision at this tree, which is over there. That's the idea of covert attention, and it's defined in the notes portions of the slides. Covert attention is when you're basically paying attention to something, but that thing that you're paying attention to is in your peripheral vision. You are not looking directly at it. Contrasting that with overt attention. Overt attention is I'm looking directly at something and I'm paying attention to it. So that's like a terminology type of thing. Most of the examples that we're going to talk about regarding visual attention in this chapter will be of the covert variety. Oftentimes in psychology, researchers will study attention to things which are in your peripheral vision. That's the primary way that attention is studied, at least in the visual modality. We'll also discuss the distinction between voluntary attention versus involuntary attention. So some synonyms: voluntary or endogenous. Involuntary also means exogenous or reflexive. So for voluntary attention, this is the idea that you have control over how your attention is deployed. Like right now, I'm using my peripheral vision to pay attention to the tree. But right now, I've switched my peripheral vision, so I'm now paying attention to the dresser, which is over here to my right. I'm kind of choosing where I'm paying attention to. That's voluntary or endogenous attention. The motivation to move my attention is coming from within my own mind. contrasting that with involuntary or reflexive attention. This is the idea that sometimes our attention can be stolen or captured by some type of salient or surprising thing which occurs in the environment. So like an example is if, like right now I'm working upstairs, but my daughter is downstairs. Earlier today I was in a meeting and I heard my daughter starting to cry, and I was really wondering why she was crying. And I noticed that during the meeting I was my attention was stolen from the meeting. I was trying to pay attention to the meeting, but my daughter was crying, and it kind of reflexively stole my attention. It's like, why is my daughter crying? I would like to know, but I couldn't go figure it out, because I was in the middle of a meeting. That's involuntary attention. The idea that your attention could be captured or stolen is kind of reflexive, something you do not have control over. So before we get into those different types of attention, I'm just gonna, this is an aspect of attention which is oftentimes talked about in cognitive psychology class, and cognitive psychology classes. And so I'm actually stealing this from a cognitive psychology textbook to talk about it, because these are some of the really, really crucial findings behaviorally about attention. But the type of attention we're talking here is auditory attention. So in the cognitive neuroscience textbook that we use in this class, most of the examples of attention are visual. And so I wanted to include some good behavioral research on auditory, which is what this research that we're going to talk about here is. Then we'll get more into the visual research and the brain findings related to the visual research that comes primarily from our textbook. So shadowing is a type of task where a person is actually wearing headphones, just like I am right now. And it involves dichotic listening. As you can, di refers to two. So dichotic listening is the idea that you're actually in your ears, one ear, there's one stream of, usually it would be speech sounds. So there might be one person talking over here and saying, a couple sentences, but then there'll be a different person or saying different sentences over here. So it's like two different conversations, one conversation over here, another conversation over here. The auditory stimuli are presented in both ears. But in the shadowing task, you're told to attend. The researcher asks you to pay attention to only one ear. So you're paying attention to one ear and you're ignoring the other. The way they do this is shadowing. Exactly what it means is you're repeating the speech sounds presented in one ear. So basically that's like whatever I hear in the left ear, as soon as I hear it, I'm going to say it out loud. So I'm saying whatever's in the left ear out loud. And basically that requires me to ignore whatever's going on. I pay attention to the one ear, and I say whatever I hear out loud, and then whatever occurs in the other ear, I don't say it. So I'm paying attention to one ear, and I'm basically ignoring the other. That's the basics of the shadowing task. The whole basis of the shadowing paradigm is that the researchers tend to be actually interested in what is the information that you're able to process in the ear that you are not paying attention to. So you're paying attention to this one ear, but it's kind of like a trick. The researcher tells you, pay attention to all this stuff in one ear. What the researcher is really interested in is what is the information that you're able to process in the ear you're not paying attention to. So it's kind of a trick. But the types of information that you're able to process, even when you're not paying attention to it, there's some interesting findings here, and that's what we're going to start talking about here. So here's an idea. There's these filter theories of early selection, and there's also a filter theory about late selection. And I'm going to present the evidence for each. And so you need to think about when we're talking about early selection, these filter theories, it's the idea that what attention does is it selects certain types of information, and that's the information that we process, and that the rest of the information will be ignored, will not be processed. But there's this question is, what exactly is the type of information that we're selecting, and what exactly is the information that's not being processed? And so the key findings here are described here in the shadowing task. The content or meaning of the information in your ignored ear, probably is not surprising, usually is not remembered. So the key, like the most common finding, or probably the most famous finding in this regard, is they do studies and you're paying attention to one ear and you're shadowing this. So you're saying whatever you hear in this ear out loud. But then in the other ear, there'll be a person talking. And halfway through this person talking, let's say the person starts out speaking in English. And then halfway through, they start changing to Russian. They start speaking Russian, or they start speaking Spanish. That's a change in the meaning. That is a change in the content of what is being spoken in the ear that you are ignoring. And maybe it's not really surprising, but people tend to not be able to process that information. If you ask the person after they're done, they just did the shadowing task, and you ask them, okay, so in the ear that you were not paying attention to, did anything change halfway through the experiment? The correct answer would be yes, the language of the speaker changed. But because most people are not paying attention to it, because they're not able to process the meaning of the things that they are processing in this ear, the ability to detect that the language of the speaker in the ignored ear changed, they weren't able to detect that. However, what is really interesting about these findings is the second bullet point right here. Even when you're ignoring what's going on in this ear, if all of a sudden, if the change in this ear is not related to meaning, instead it's related to sensory features, then you are able to notice that even if you're not paying attention. So for instance, a common way that this is studied is this is the ignored ear right here. And the person in the ignored ear will start as a man speaking. Men tend to have lower pitch voices. And then halfway through, the voice will change to a high pitched voice. And then after the experiment, the researcher will ask, did anything change in the ear that you were ignoring? And the correct answer would be, yeah, the speaker's voice changed. It went from a man to a woman, or it went from a low-pitched voice to a high-pitched voice. And what they find is that the participants are actually highly likely to be able to detect the sensory change, even though they were not actually paying attention to the information in that ear. So this is the early selection. This is evidence and support for early selection. Basically, what this says is the information will not be processed when you're ignoring it if that information involves some type of content analysis. You are not able to process the meaning or content of things that you are ignoring. However, even if you're not paying attention to something, you are still kind of able to process sensory features, whether the thing that you are ignoring is being spoken by a man or woman. You kind of process that information even if you're not paying attention to it. Even if you're trying to ignore it, you kind of automatically process the pitch of the speaker's voice. So this is evidence and support for early selection. Late selection, the evidence for this is shown right here. So using the exact same paradigm, the shadowing task, once again, people are told to repeat everything that they hear in one ear, and then they ignore everything in the other ear. The evidence that we just saw in the previous slide suggests that when you're ignoring this ear, you're not paying attention to the meaning of the words that you're hearing. The language changes. You're not able to process that language changing in the ignored ear. There is an exception, though. There is an exception. That's what there's a couple exceptions, actually, and I'm going to show you those exceptions right here. And these selections provide support for this idea called late selection. So the coolest example, I think, it's cool and it's also easy to understand, is that people, if you're paying attention to this ear and you're ignoring what's in this ear right here, but in this ear, one of the things which is spoken is your name. Someone says Matt Rosenthal in the ignored ear. I'm trying to ignore this, but special words that have special meaning to you will actually pop out. And then the researcher will say, so did you hear anything interesting in the ear that you were ignoring? And then the participants will often say, yeah, I heard my name in that ear. I heard my name in the ignored ear. They will not have heard any other words in the ignored ear, but there's something about their name which pops out to them. Part of the reason that, what's important about this finding is that it shows that we actually, even when we're ignoring something, we actually are paying attention to the meaning of this stuff that we're ignoring, at least to a small extent. Because what your name is, the reason your name pops out to you is because it has special importance to you. It has special meaning to you. So even though we're ignoring this ear, and for the most part, we are not processing the meaning of the words in this ear, there are still certain words that are so important to us, that are so meaningful to us, that they will pop out. And these support this idea of late selection, the fact that even when we're ignoring something, some aspects of the meaning are still being processed. Another example that supports this idea of late selection is shown here. So this sentence right here, they were standing near the bank, is ambiguous because bank can mean two types of things. Can you guys figure it out? What are the two types of things? What are the two types of bank that exist? Anyone figure this out?
A river bank and like a financial bank.
Yes, there's a river bank and there's a money bank or a financial bank. Those are the two types. So what you would hear in your ear that you're paying attention to, the ear that you're shadowing, the one that you're repeating everything, they would say they were standing near the bank. In the ear that you were ignoring, you would hear one of two words. You would either hear something about a river or you would hear something about money. And what they find out is that what happened, like later on, they'll ask you, okay, so in the ear that you were shadowing, in the ear that you were repeating everything that you heard, you said they were standing near the bank. What type of bank was the person standing near? And in this ear, they didn't actually say what type of bank it was. It was in the ear that you were ignoring that they provided information about the type of bank that they were standing to. So you're ignoring this ear, but it turns out that the information that is presented in this ear influences, it biases your perception of what occurs over in this ear. So if in the ear you were ignoring, they were saying something like about a river, then when the researchers later asked you, so what type of bank were the people in the ear you're paying attention to, what type of bank were they standing next to? You'd say is a river bank. Or if they were talking about money in the ear you were ignoring, and then they asked you what type of bank were they standing next to, you would say, oh, they were standing next to a financial institution, a financial bank. So this once again supports this idea of late selection, because even when you're ignoring your ear, some elements of meaning were actually still being processed. Really, there's two types of meaning that were being processed. It's really special things like your name. And then, at least in this evidence, the second study suggests that there are some types of meaning that are processed, whether it's a river bank or financial bank. So both of these provide evidence for late selection. And what both of these studies have in common is that they suggest that even when you're ignoring something, there are some aspects of meaning which are being processed. The early selection models, these theories suggest that when you're ignoring something, you're not getting any meaning information which is being processed. But the late selection models say, okay, there's some types of meaning that actually are being processed in these studies, even when you're ignoring it. So anyone have any questions or comments about the difference, about these findings from these two studies and how they support early versus late selection? All right, don't hear any questions, so we will move on. Okay, so now that was just supposed to provide kind of a basic cognitive overview of attention. And it was also supposed to give an auditory example of attention, because there's not a whole bunch of auditory examples of attention in our textbook. So now we're going to get into some of the visual examples of attention which are provided in our textbook, and we will talk a little bit more about the underlying neural mechanisms. Okay, so there's a lot going on in this slide, but really what I want you to know is that what's described here is voluntary attention, or as I mentioned earlier, it's also called endogenous attention. This is the type of attention where you as the participant are thought to have control over how your attention is deployed. I can either focus my attention on the tree in my left peripheral vision, or I can focus my attention on the dresser, which is in my right peripheral vision. So the way this stuff is studied in the laboratory is they use what's known as a symbolic cue. And the symbolic cue here is an arrow. Really, the most crucial feature about a symbolic cue is that it's not reflexive. It's not something that that steals your attention. Like earlier I mentioned, like when my daughter cries, it steals my attention, it makes it hard to pay attention to anything else. That would be a reflexive cue. An arrow is not reflexive. An arrow is something that you understand the meaning of it. It has a symbolic meaning. When I see this arrow right here, I know the meaning of that is, okay, move my attention to the right, and then I use my free will or whatever to move my attention over to my right periphery. Or if I see this arrow to the left right here, I know the meaning of that, and so I can say, okay, now I'll use my free will to move my attention to my left peripheral vision. So the symbolic cue in these studies, and almost I think every single voluntary attention study that I've ever seen, at least with the visual system, the symbolic cue is an arrow, which basically tells you, move your attention over here, please, or move your attention over there, please. The task in these studies is you see some type of an object that will appear, and your task is to respond to that object as quickly as possible. So in this little schematic diagram here, the object that you're responding to is this little square. When the square appears on the screen, press a button on the computer as quickly as possible, and the dependent variable in these studies is reaction time. So a couple more things I need to talk about, because these are crucial elements of the voluntary attention paradigm, is this idea of a valid trial, an invalid trial, and a neutral trial. In a valid trial, the arrow tells you to attend to the right visual field, and then the object that you are processing occurs in the right visual field as well. So that's a valid trial because the cue tells you to attend to the visual field that the target object that you are asked to process actually occurred. Contrasting that with an invalid trial, so for this example, the cue tells you to pay attention to the left visual field, but the target that you're actually processing occurs in the right visual field. So this is like a fake out here. They're like, pay attention over there, but then the thing that you actually have to respond to occurs in the opposite visual field. And what they want to know here is, does your reaction time to process this object, is it influenced by where your attention is deployed? Oh yeah, and the one more, the neutral cue. The neutral cue, in the neutral trial rather, the attentional cue is ambiguous. So here the arrows are pointing both ways, and basically that's like, okay, the target that you're going to process, it might occur in the left or it might occur in the right. So it's ambiguous. That's why it's a neutral cue. And the dependent variable here, once again, is reaction time. And you don't care about the difference between the red and blue lines. You don't care about the difference between the red and blue lines. What you care is the general angle of these lines, which both of them have. They're similar. And I guess a question I have for you, in which of these three types of trials, looking at this graph right here, which of the three types of trials, valid trials, invalid, or neutral, in which of these three types of trials are participants' reaction times the quickest?
Valid trials.
It is valid trials. So valid trials are shown right here. And then you can see right here, here's the reaction times for the valid trial. So it looks like the reaction time here is around 240 milliseconds, maybe. And then we look at the neutral trials. The reaction time is a little bit higher, maybe around 270 milliseconds. And then we look at the invalid trials, and the reaction time is around 300 milliseconds. And so what we're showing here is that where your attention is deployed influences the rate, the amount of time it takes you to respond to an object that occurs. When you're paying attention to one side of space and then an object occurs in that one side of space, you're able to process that object a little bit faster than if you're paying attention to one side of space and then the object occurs on a different side of space, in which case you're a little bit slower to respond to the object. Any questions or comments about voluntary attention? So that's the behavioral paradigm. We will now get into some of the brain findings soon. First, I just want to tell you a little bit about when we're doing this voluntary attention paradigm, there's a whole lot of points in time in which we can be measuring participants' brain responses. Really, there's three, if you look in the literature, there's basically 3 points in time to which we can measure participants' brain responses. One, in response to the cue. Someone remind me before we forget. What was the cue in the slide that I just showed? What was the cue?
The arrows.
The arrow, thank you. The arrow is the cue. And so I can look at your brain response to the arrow, whether it's pointing left or right. That's one thing I can measure your brain response to. A much more common brain response is, what is your neural activity during the preparatory interval? So the preparatory interval is the cue occurs, and then the target that you're going to respond to occurs some amount of time later. So that amount of time between the cue occurs but before the target is presented. That is the preparatory interval. You as the participant, your attention has been deployed, but you're waiting for the target for which you are supposed to respond. That is the preparatory interval. This is actually probably the most common point. This is it's one of the more common points in time in which the brain has responded. While we're waiting for the target to respond is a common, and I'll show you some a study about neural activity during the preparatory interval here in a second. The third type of brain response, which is also often recorded, is a response to the target. So the target in the previous study was that square, and I can measure your brain response to the square in those conditions in which you are paying attention to the point in space in which the square occurred. And I compare it to those trials in which you were attending to a different point of space to which the target was occurring. So these are the three different types of, 3 different points in time in the voluntary attention queue in which neural responses are often measured. The ones that we care most about are the neural response during the preparatory interval and the neural response to the target. And I'll show you neural data for both of those. I think that's what we're getting to, here in a second. First, before we do that, I do want to do a review of frequency analysis, because one of the studies, I'm going to show you a study that measures neural response during the preparatory interval, and they use a Fourier analysis. In particular, they're looking at the amplitude of alpha oscillations, the amplitude of alpha waves. And we talked about this way back in chapter 3, I believe. So it's been a while. So I don't want you to forget what Fourier analysis is. This is the idea that if we're measuring with the EEG, that is, we're measuring your electrical activity from the scalp, we're measuring with electrodes that are placed on your scalp. Fourier analysis is the idea that we're taking that EEG waveform, we're taking the electrical activity that's being measured on your scalp, and we're decomposing it into various sinusoidal components of different frequencies. So this would be, once again, I've shown you this before, this should look familiar. This would be like the raw EEG signal, but we can decompose it into this component, and this component. For instance, this one right here, would this be considered the low frequency component or the high frequency component?
Low frequency?
Yeah, it's low frequency. It's low frequency. Whereas this one right here is high frequency. High frequency means that the wave is moving very fast. There's a whole lot it goes peak to trough, peak to trough, peak to trough very, very quickly, which is what we see here. So this one is high frequency because the wave is moving very fast, going up and down really quick. Here, the wave is moving relatively slower. It's waxing and waning. It's going from peak to trough relatively more slowly. And so this is Fourier analysis, breaking down the complex EEG waveform into low frequency waves, middle frequency waves, and high frequency waves. The one that we're going to be interested in is alpha amplitude, which I'll show you in a second, which would be considered a middle frequency band. We've shown you this before here. Gamma is high frequency activity. Delta is considered low frequency activity. And then alpha, which is the one that I'm going to show you in a slide here, 1 or 2 slides here. This is the one this is considered middle frequency activity. It's 8 to 12 hertz, whereas gamma is high frequency, 30 to 100 hertz, and delta is around 4 hertz. So I also want to remind you that we haven't talked tons about event-related potentials, but I want to remind you what event-related potentials, what they do, what they measure. An event-related potential, we talked about these in chapter 3, it measures electrical activity measured using EEG on the scalp, but it measures that EEG amplitude at a specific time point relative to the onset of some stimulus that the researcher cares about measuring the brain response to. So for instance, you guys remember the N170 event-related potential? Does anyone remember what is the type of stimulus that we usually measure the N170 in response to?
Faces.
It is faces. What is that 170? What does that 170 mean in the N170?
At 170 milliseconds.
Yeah, well, relative to what?
The stimulus.
Yeah, which is the face. So in the N170, I present you a face on a computer screen. 170 milliseconds later, that's when you see the event-related potential. That's when you see that negativity, the N. It occurs 170 milliseconds approximately after the face is presented. With event-related potentials, we're using EEG to measure the amount of amplitude that occurs in response to a stimulus a certain amount of time after that stimulus is presented. One thing which is really important, and this is, when I was an undergraduate student, I remember one of the hardest things for me to understand is, what is the difference between Fourier-analyzed EEG studies versus event-related potential studies? And there's really important difference. The most crucial difference is that when we're talking about event-related potentials, like the N170, we're not doing a Fourier analysis. In an event-related potential study like the N170, we're basically using the raw EEG amplitudes, but we're not breaking those EEG amplitudes into the sinusoidal components of different frequencies. So ERP studies, event-related potential studies, we're looking at EEG amplitude, but we're not studying specific frequencies. In ERP studies, we're not really interested in gamma. We're not interested in alpha. We're not interested in delta. We're just looking at raw EEG, the raw electrical activity. It is relative to a certain point in time after a stimulus presented. So important thing to understand the difference between event-related potential studies, which do not use Fourier analysis, and then studies which do use Fourier analysis. So now I'm going to show you some actual neural data. First, I'm showing you, this is basically just showing you the specific stimulus setup for the study that we're looking at here. It's basically it's a voluntary attention study, but it's a different picture. I've basically shown, this is a schematic diagram of the voluntary attention paradigm. I already showed you one 3 or 4 slides ago. The one I showed you 3 or 4 slides ago is from the textbook. The one I'm showing you right here is from an actual article on electrical physiological responses during voluntary attention. You look here, can you guys tell me, well, what is the cue in this? Can you guys tell what is the cue in this study? The attentional cue.
An arrow.
Once again, it's an arrow. That's why I said, to my knowledge, I've never seen a voluntary attention study where the cue was not an arrow, which is telling you to deploy your attention either to the left or right visual field. That every single one, there might be some that exist. Every single one that I've read, it's always an arrow. And you can see that right here. The arrow is telling you either point to the right, or the arrow is telling you to point to the left. Then there's the delay. This delay, by the way, is the preparatory interval. It's 1,000 milliseconds here. And in the study I'm about to show you, what they were really interested in was the neural response during the preparatory interval. That is the neural response during this delay interval. So this is, we present the cue. And then what we're really interested in is what's the brain doing while it's paying attention to one part of space, but it's waiting for the stimulus that you're going to respond to be presented. Then the stimulus is presented. Here, the stimulus is presented in the left visual field, or down here is presented to the right visual field. And then the trial's over. And then there's a little delay before you start over, and then you do another trial. So this is kind of a schematic diagram of the way this particular study, this is Fox et al., with the way they did their particular study. So here's the data. There's a lot going on here. Here's the graphs from this study. So there's a whole lot going on. So I'm going to move this little thing. So you can maybe, there we go. There's a whole lot going on in this study. So one of the things I like about the study is that they went ahead, they did an event-related potential analysis. And that's what's shown up here on top. So it says ERP. So the top row, this is event-related potential analysis. And remember, the event-related potential analysis is just using the raw EEG amplitude. It does not do a frequency analysis. It does not break the electrical activity into the different sinusoidal components. So that's the first thing. The top line is event-related potential. It's not Fourier analyzed. The bottom, it says alpha. I always forget what that TSE stands for, but just know that this is basically alpha amplitude. The bottom is just alpha amplitude. And so this is Fourier analyzed. They're looking at the middle frequency, which is alpha. And so that's it. So the top part is event-related potentials, not Fourier analyzed. The bottom part is looking at alpha amplitude. And so it is Fourier analyzed. So there's a couple more things. There's a lot going on in these data. It was a complicated study, and we're going to kind of break it down a little bit. So another thing is this left column. This is looking at brain responses in the left hemisphere of the brain, and you can see that. This is a person right here. This is the person's nose, left ear. This is the right ear right here. And this arrow, this is the electrode position. This is the left occipital lobe right here. The electrodes were placed over here on the person's left occipital lobe, and these are the brain responses. This is the event-related potential response over the left occipital lobe, and this is the alpha amplitude response from that same electrode over the left occipital lobe. Going over here, this is the brain activity in the right hemisphere. So this is the right hemisphere, the right occipital electrode right here. This is the event-related potential response to that right hemisphere occipital electrode. This is the right hemisphere response of the alpha amplitude of that right hemisphere occipital electrode. A couple more things. The zero time point is important to know. The zero time point, well, we're measuring during the preparatory interval, and it says it up here, during the preparatory interval. So what is the zero time point here? If we're measuring during the preparatory interval, when does the preparatory interval begin? What is the zero time point, in other words? Anyone have any idea? The preparatory interval begins when what happens? I'll give you a clue.
Isn't it after the stimulus?
It's not after the stimulus. It's after something, but not the stimulus.
Oh, after the cue.
It's after the cue. Exactly. Thanks. I know that it's a little challenging, so that's why I asked, but that's an important thing to think about. There's actually right here, time point 0, and also time point 0 right here. This is the onset of the arrow. This is the onset of the attentional cue. We're measuring activity during that preparatory interval. So after the cue is presented, but before the target to which we are responding occurs. And you can actually see that here. If you remember the slide I showed you, it was at 1,000 milliseconds or 1 second. And that's what we're seeing here. Right here, this is when the cue is presented. And this is the brain activity during that 1,000 milliseconds. And right here, this dotted line, that's when the target is presented. So the target to which you respond is present right here. So this whole thing, this is the preparatory interval. This whole thing, this is the preparatory interval. This whole thing is also the preparatory interval, and this whole thing is also the preparatory interval. So time point 0 is the presentation of the symbolic cue, the arrow. And then at time point 1,000 milliseconds or 1 second, that's the presentation of the target to which you are making a response. This study was interested once again in the neural activity during the preparatory interval. So there were some weak findings in the event-related potential study. But if you see the red and green lines here, they basically overlap almost completely. There's not a whole lot of difference here. So we'll come back to that. But I think it'll be easier to understand the study if we first kind of decompose what's going on down here in the bottom. So there's some important stuff going on down here for the alpha amplitude. So I want to remind you, this right here is the left occipital lobe. And the idea of contralaterality says that your left occipital lobe is going to respond to stimuli and most strongly that are in what visual field?
The right.
Yeah, it'd be the right visual field because this idea of contralaterality. The question that they were asking in this study is, how does the brain activity during the preparatory interval, how is it influenced depending on whether you're paying attention to the ipsilateral hemifield or the contralateral hemifield? So right here, we're in the left hemisphere. The green line represents brain activity when people are paying attention to the ipsilateral hemifield. So this is the left hemisphere brain activity. The green line means the cue is pointing to the left visual field. So the green line is when people are paying attention to the ipsilateral hemifield here. Left hemisphere, paying attention to the left hemifield. That means it's on the same side. Versus this red line, this is the left hemisphere electrodes, but this red line right here is when people are paying attention to the contralateral hemisphere. They're paying attention to whatever's going on the right side. And you can see there's quite clearly a difference in brain activity here. alpha amplitude, well, you tell me, I want to make sure you guys can read this. In this left hemisphere electrode, was alpha activity during the preparatory interval greater than or less than when people were paying attention to the contralateral hemifield?
Less than.
It is less than. Excellent. When you are paying attention to the contralateral hemifield in this case, so the red is the contralateral. This is the left hemisphere electrode. When I ask about contralateral, basically what I'm saying is, what is the brain activity doing when they're paying attention to the right side of the world? And you can actually see that the alpha amplitude is smaller in the left hemisphere when you're paying attention to the right visual field. Now, at first, that might seem kind of weird. You know, you're paying attention to something, and, you know, the contralateral organization of the brain, you would think, okay, well, it's in the left hemisphere. I'm paying attention to the right side of the world, but the brain response is decreasing. That's kind of weird, right? But we have to remember something important about alpha amplitude. The thing which is important about alpha amplitude is that alpha amplitude is the brain signal which, when your eyes are open, when you're engaged with the world, alpha amplitude tends to get smaller. And when your eyes are closed, alpha amplitude tends to get bigger. So it's kind of a counterintuitive thing, but when your alpha amplitude is small, that's when you're most attentionally engaged with something. And so we're seeing that the alpha amplitude is smallest when you're paying attention to the contralateral side of the world. This actually suggests that, you know, this left hemisphere of the brain is paying more attention to the right hemifield. Now we're going to switch over here. This is the right hemisphere electrode. Tell me, how are things different over here? How is this graph over here different than this graph over here? Can someone tell me, how do these graphs, how are they different?
The alpha amplitude in the left lower Q field is smaller than the one on the right.
Yep, it's like things flip-flopped. But this makes sense once it makes sense once we remember what alpha amplitude is supposed to measure. When alpha amplitude is small, that's when you're most attentionally engaged. When alpha amplitude is big, that's when you're kind of sleepy. That's when you're not paying attention. So we're measuring from the right hemisphere. And you look at, we would expect the right hemisphere is going to be most engaged when we're paying attention to stuff in the left side of the world. And that's exactly what we see here. When the Q is telling you to pay attention to the left side of the world, alpha amplitude, this green line, is smallest. And so what's cool about these studies is they show that alpha amplitude seems to be a really strong measurement of attentional deployment. Each hemisphere, the alpha amplitude decreases when you're paying attention to the contralateral side of the world. And really, the main thing I want you to know about this study is the findings from alpha amplitude. That's really what I want you to understand about this, is what we just talked about. There are also some findings in the study where they talked about these event-related potential findings. But as you can see, they're small here. There are some small differences between the red and green lines here, but they're small, whereas the differences for alpha amplitude are very big and robust. And so this is the alpha amplitude stuff is what I want you to remember. It's stuff about ERPs in the study I'm not going to require you to know. I do want you to understand, though, that ERPs do not use Fourier analysis, whereas alpha amplitude does. Okay, so that study's a doozy. That's a tough one. But it's an important study. It's published relatively recently, and it's a really robust finding, so it's important. Any questions or comments about this one?
Has it been replicated in other, like, has other people tried to do this study as well?
I'm curious to know why you're asking. And that's an interesting question, because the only person that I know who has replicated this was Fox, who was the person who published this. So he published this in one year, several years ago. And then he published it again several years later and was able to replicate his own findings. But to my knowledge, I have actually not known of any other researchers who have tried to replicate this. Which actually, I'm surprised you asked that, but it's one of my things which annoys me about this study is I would actually I'm kind of skeptical about it. I would like to know whether this would replicate if other researchers did it.
Yeah.
Is that the reason you asked, is because you're skeptical?
Yeah, pretty much, because it's such a strong effect. I was wondering if other people had also observed it.
Yes, in my psychophysiology class, which I taught this fall semester, we tried to do kind of this study. We tried to kind of replicate the study. We changed a few things so it wasn't a perfect replication. But I will say so there's some things that we might have done wrong, but we were actually not able to replicate this study exactly. But we weren't replicating it perfectly. So next year when I teach 625 again, I'm considering actually doing a more close replication of this to see if we are able to actually get it when we do it. But yeah, so great question. Your skepticism, I'd say, is justified because it's only been replicated once and it was by the same author. And I'm always skeptical until I see a finding replicated by multiple authors. Hopefully Fox doesn't watch the YouTube recording on this or else he's gonna be mad. He's a big deal. He doesn't care about little of me. Okay, so moving on then, the study that we just looked at, this will probably be, how are we doing on time here? No, we're gonna call it a day here, actually, and that one was pretty dense. So we'll call it a day, and now you guys can do your Master and His Emissary quiz. That is today, I believe. So I'll show you the questions here, and then I'll post the submission thing on Blackboard. We'll start here talking about event-related potential responses to the target next time. Let's get Master and His, oops, I don't want to stop the video. Here's Master and His Emissary questions for today. There they are. Okay, yeah, people did not get the email.